Today I'll solve unsteady mass balance, mixing tank problem or simultaneous first order ODE by using RK4 method. So problem is here, tank A has an inlet pipe flowing at 3 gallons per minute and outlet pipe filling tank B at 4 gallons per minute. A pipe flows from tank B back to A at 1 gallon per minute. The diagram will make this clear. Let's assume both tanks are 50 gallons and tank A contains 25 pounds of salt initially and tank B contains no salt initially. Further, assume that pure water is entering tank A. So here two tanks are there. So one tank A and another is B, and both tank has volume that is 50 gallon. Tank A has initially 20 pound salt initially, and tank B no salt is there, and one fresh water is coming tank A. Another inlet is also there, so that is actually coming from B. For tank A, so that fresh water is coming 3 gallon per minute, and from tank A another outlet is there, so that is 4 gallon per minute, so that is coming to the B. And from the B, the one outlet is, two outlets are there, so one outlet coming back to the A, another is going outwards, so that is 3 gallon per minute. Now here we have to do the mass balance and obtain ordinary differential equation. So here as two tanks is there, so if we do the mass balance for tank A and tank B, we'll get two first order ODE, and then we have to solve these two first order ODE simultaneously. So that I'll solve, and I'll solve that two ODE by using RK4 method, and then I'll write the code, MATLAB code, and again I'll validate that code by using ODE 45, and then I'll plot all these means I'll plot RK4 method or inbuilt function. So here I'll not do that Euler method because it will be lengthy for this video, so I'll not do that right now. So I'll just solve by RK4 method, and then I'll plot that solution, means solve concentration in MATLAB. I'll show you how it means what will be the solution for this problem. Now this is mixing. So two tanks are there. So this is mixing tank system. So now first we have to write the general mass balance equation. So we know that. So rate of mass accumulation is equal to rate of mass input minus rate of mass output plus rate of mass generation minus rate of mass accumulation consumption. As there is no chemical reaction happening here, so rate of mass generation and mass consumption is 0. So if we just do that, means rate of mass generation and mass consumption is 0. So rate of mass accumulation is equal to rate of mass input minus rate of mass output. And before that, we have to assume that liquid is perfectly mixed with the salt and concentration of the solution is uniform. So that assumption we can take that. And finally, so we have the mass balance equation. So rate of mass accumulation is equal to rate of mass input minus rate of mass out. Using that mass balance equation, so we will get two ordinary differential equation. Now how do you get that? Now here, so we are doing that solve balance for tank A. So now is what we have to assume. So assume that salt concentration of the tank A, so that is Ca. Ca is the salt concentration, and Cb is the salt concentration of tank B, and fresh water salt concentration C0B, that is 0 pound per gallon, and volume of each tank is 50 gallons, so that is given. Okay. Now here initially salt 25 pounds salt is there. Now we can easily calculate what will be the concentration initially, so that we will do that. Now here first salt balance for tank A. We know the rate of mass accumulation is equal to rate of mass input minus rate of mass out. Now if we do the salt balance, so rate of mass accumulation of salt for tank A is equal to dm by dt, so d by dt of m, that is nothing but d by dt Ca into V. So we know the concentration Ca is that pound per gallon, okay, or you can write m by V. So Ca into Va is nothing but m by V into V, so that will be m, means rate of mass accumulation of salt is d by dt Ca into V. Now rate of salt input is, so here for tank, so that is input, as here no salt is coming, so we can write 3 into C0, so C0 is here, so that is 0 pound per gallon, plus 1 into Cv, so another inlet is here, so and we assume that concentration of the B is Cv, so that is 1 into Cv. So now that concentration of that freshwater salt concentration is 0, so you can write 3 into 0 plus Cv. So here ultimately, so this is 0 only Cv. And rate of salt output, so that from the tank one outlet is there, so that is that volumetric flow rate is 4 gallon per minute, so you can write, and concentration of the tank A, the Ca, so you can write rate of salt output is 4 Ca. Now if you put together, so one equation will be, so if we put together d by dt Ca into Va is equal to Cv minus 4 Ca. Now here that volume of the tank, volume of the Va is 50 gallon, so you can write d by dt Ca into 50 is equal to Cv minus 4 Ca. So dCa by dt will be Cv minus 4 Ca by 50. So that is the first equation for tank 1 or A. Now similarly we have to again do the mass balance for tank B. So for tank B, again rate of mass accumulation is equal to rate of mass input minus rate of mass output. So rate of mass accumulation for this, so the d by dt m and d by dt Cv into Vv. And rate of salt input, so here that is the one input, so 3 gallon per minute volumetric flow rate is that one solution is coming to the B tank. The salt input and concentration of the salt is Ca. The tank solution that in tank A, solution concentration is Ca, so we can write 4 into Ca, so that is volumetric flow rate into concentration, so that will be rate of salt input. And then rate of salt output, there is two output, one is the top, another is bottom. So and tank B salt concentration is Cv, so we can write 1 into Cv, so that is flow rate, and this is the concentration, this is again flow rate and concentration. This flow rate is 3 gallon per minute, so outlet concentration. So ultimately that rate of salt output is 4V. Now if we write together, what we will get? So this is the equation, accumulation input and output. So d by dt CvVv is equal to 4Ca minus 4Cv. Now if we write d by dt, again Vv we know, so that is 50 gallon. So if we do the balance, so d by dt Cv50 is equal to 4Ca minus 4Cv. Now if we take only dCv by dt, so that will be 4Ca minus 4Cv by 50. So that is the equation for tank B. So now two equation, earlier we got one equation and now another equation. Okay, so now we can, if we write that, so dCa by dt is equal to Cv minus 4Ca by 50, dCv by dt 4Ca minus 4Cv by 50. So equation 1, equation 2. Now condition, initial condition, tank A contains 50 pound salt and tank B contains no salt. Now at T is equal to 0, what will be the concentration? So amount of salt by volume of the tank, so that is 25 by 50, so that will be actually 0.5, and tank at T is equal to 0, Cv will be amount of salt by volume of the tank, so 0 by 50, so that is 0 pound per gallon. So now initial condition we have at T is equal to 0, Ca is equal to 0.5 and Cv will be 0. Now what will be the solution strategy? Solution strategy, so we have to solve simultaneously. So we have two ODE, so simultaneously we can solve that. Solution strategy: solve ordinary differential equation by using RK4 method and MATLAB inbuilt function. Now how do we solve? First I will show the hand calculation, then I will show MATLAB code. Now hand calculation. So now here two equation, so we can write dCa by dt is equal to Cv minus 4Ca by 50. So that is the function of f1. So we write as a function 1 T, Ca and Cv, and dCV by dt, so that is 4Ca minus 4Cv by 50. So that is function 2, that is function of t, Ca and Cv. At t is equal to 0, Ca is equal to 0.5 and Cv is equal to 0. Now we know that RK4 method, so simultaneously we have to solve. First we have to find out, so this is that function 1 and this number, okay. So that is function of function 1, Ti, Cai and Cvi, and K12, so this is the function number, so this is again, so function number. So for this equation, so we are calculating K11, that is F1, Ti, Cai and Cvi, and this equation for K12 is F2 function of Ti, Cai, Cvi. Now K21 is actually function of Ti plus half of H and Cai plus half of K11. Okay, so because for this equation K11, so that Cai plus 1 by 2 K11H, and Cvi is for this is function of that T, Ca and Cv will be Cvi plus half of, so whatever K2 we are calculating K12 into H. So for K22 also F2 Ti plus half of H, okay, Cai plus half of K11, so whatever if we get K11, so that K11H, and Cvi plus half K12H. So you have to remember that how to actually we formulate that, okay. So this is very important. If we know, then a calculation will not be here. So for this equation, first we have to calculate K11, K21, K31, K41, because this equation, this is dCA by dt, and this equation dCV by dt. So for this equation we have to calculate K11, K21, K31, K41. For this equation again we have to calculate K12, K22, K32, K42. So tricky part is, so when we take the function of Ca and Cv, so for that we have to take the consideration that slope. For Ca1 we have to take that slope K11, so that is Ca1 plus half of K11. For Cv we have to take that slope K12, Cv plus half K12H. So K22 again we can calculate F2 Ti plus half H Cai plus half of K11, so this slope H, and Cvi plus half of K12H. And K31 F1 of Ti plus half of H Cai plus half of K21H and Cvi plus half of K22H. And K32 is equal to function of 2 Ti plus half of H Cai plus half of K21H and Cvi plus half of K22 into H. And ultimately and K41 is equal to F1 Ti plus H and Cai plus C31H and Cvi K32H. And K42 F2 plus Ti plus H Cai plus K31H Cvi plus K32 into H. So you have to remember how, and simultaneously we have to calculate, okay. And next step, so whatever K11 and K2 we got for the calculation, so that will come to the calculation that will required for calculation that is required when we are going to calculate K21 and K22. Now finally Ca1 will be, after getting all this slope, so Cai plus 1 is equal to Cai plus 1 by 6 K11 plus 2 K21 plus 2 K31 plus K41 into H. And Cvi plus 1 Cvi plus 1 by 6 K12 plus 2 K22 plus 2 K32 plus K42 into H. And finally that increment of the time step Ti plus 1 is equal to Ti plus H. So these are the formula, using this formula. So this is second order ODE, two first order ODE simultaneously we are solving. So we have to remember this formula, and then we will do that hand calculation. Now here, so this is though it is maybe complicated, but it is not. Now here, so dCA by dt is equal to Cv minus 4Ca by 50. So F1 T Ca Cv, and dCV by dt is equal to 4Ca minus 4Cv by 50. This is function 2 T Ca Cv, and T is equal to 0, that Ca is equal to 0.5, CB is equal to 0. Now we are going to calculate K11. K11 is equal to F1 T0 CA0 CB0. Now T0 means 0, CA0 means 0.5 and CB0 is 0. Now we have the equation CB0 minus 4 CA0 by 50. So you can put that CB0 0 minus 4 into 0.5 by 50. So minus 4 into 0.5 by 50. So that is minus 0.04. That is K1. And K2 simultaneously we have to solve that. We have to find out K12. So that is F2 T0 CA0 minus CA0 and CB0. T0 means 0, CA0 is 0.5 and CB0 is 0. Now we know the equation. So that is 4 CA0 minus 4 CB0 by 50. So 4 into 0.5 minus 4 into 0 by 50. So ultimately we will get 0.04. Now after getting K12 and K11, so now we are going to calculate K21. K21 is again F1 is into T0 plus half of H, CA0 plus half of K11H and CB0 plus half of K12H. Now here T0 plus half of H, H we are taking, that is 0.1. So 0 plus half into 0.1. Okay, so this is T0. Another is CA0. CA0 is 0.5 plus half into K11. K11 already know, minus 0.04 minus 0.04 into H 0.1. And then CB0 is 0 half into that K12 already calculated 0.04 into 0.1. Now we will get the function of 0.05 and 0.498 and 0.002. Now we have this equation CB minus 4C1 by 50. So we can put CB. So CB is here, that is 0.002 minus 4 into CA. CA here is 0.498 by 50. If we do the calculation, ultimately we will get K21 is 0.0398. Similarly for F2 again, K22 is F2 T0 plus half of H, CA0 plus half of K11H and CB0 plus half of K12H. Now here T0 is 0, half, and H is 0.1, then CA0 is 0.5, half into K11 already minus 0.04 into 0.1 and CB0 is 0, half K12 0.04 into H 0.1. Now ultimately, so T will be 0.05, CA0 will be 0.498 and CB will be 0.002. Now we know the equation 4C1 minus 4CB by 50, that will be 4 into 0.498 minus 4 into 0.002 by 50. Ultimately we will get the value after doing the calculation. K22 will be 0.0398. Now similarly again K31 is equal to F1 T0 plus half of H, CA0 plus half of K21 into H, CB0 plus half of K22 into H. So F1 will be 0 plus half of into 0.1, 0.5 plus half of half into whatever that K21 we already calculated minus 0.398 and into 0.1, and CB0 is 0 plus half of K22 is 0.0398. So that is you can plug here actually 0.03978 whatever into 0.1. So ultimately F1 will be F1 of 0.05 T CA0 and CB0, and we know the equation CB minus 4C1 by 50. So if plug that value 0.002 minus 4 into 0.49806 by 50, ultimately we will get minus 0.0398. So that is the value of K31. And K32, F2 of T0 plus half of H, CA0 plus half of K21 into H, CB0 plus half of K22 into H. So F2, so here T0 is 0, then half into H is 0.1, CA0 is that 0.5, half K21 is here, K21 is minus 0.0398 into 0.1 in this is H, then again CB0 is 0, and then half K22 is this 0.0398 into 0.1. So ultimately F2 is F2 of T, CA0 and CB0, 0.5, CA0 0.498 into 0.002, and then we know the equation 4CA minus 4CB by 50, that is 4 into 0.498 minus 4 into 0.002 by 50, ultimately we will get that K32 is 0.040. Now we have to calculate K41 and K42. The next page. So we got that K1 is minus 0.04, K21 minus 0.3988, K31 minus 0.3988, K12 is 0 minus, not this is not minus, this is plus 0.04, 0.0398, K22 is 0.04. Okay, now we are going to calculate K41, F1 T0 plus H, CA0 plus K21 H, CV0 plus K22 H. Now F1, so T0 is 0 plus 0.1, 0.5 plus K21 into H, K21 is that is not K21, so that is that typo mistakes, 31 and 32. 31 is minus 0.03988. Okay, and CV0 is K3 into 2 into H, so that is 0.04 into 0.1. Okay, ultimately that will be, this is not, this is also plus, not minus. Okay, so ultimately that F1 0.1, 0.496 that is 0.004. Now if we put together, okay, so CV will be like that. This is not minus, this is plus. Okay, and minus 4 into 0.496 by 50. So if we do that, so ultimately we will get 1.988 by 50. So that is minus 0.0396. And then K42, F2 T0 plus H, CA0 plus K31 plus CV0 K32. Now if we plug together, so T0 is 0, H is 0.1, CA0 is 0.5 plus that K31 is minus 0.03988, okay, into H. CV0 is that 0.04, sorry 0, and K32 is 0.04 into 0.1. So ultimately F2 is 0.1, 0.496 and 0.004. If we plug all this 4C1 minus 4CV by 50, ultimately we will get 0.0393. Now here we have to calculate CA1. Okay, CA1 is equal to CA0 plus 1 by 6, K11 plus 2, K21 plus 2, K31, 2K41 into H. So 0.5 CA0, 1 by 6, and all this value, okay, into 0.1. Ultimately we will get 0.4960. Similarly CB1, so that is equal to CA0 plus 1 by 6 K12 plus 2K22, 2K32, 2K42 into H. So if we plug all this value, zeros, all this value, this value, this value, this value, and this value, ultimately we will get 0.004. Now, and T1 is equal to T0 plus H, so 0 plus 0.1, so that is 0.1. So at T is equal to 0, CA is equal to 0.5, CV is equal to 0, and T is equal to 0.1. So that we got that T is equal to 0.1. We got that concentration CA is 0.0496 and CV we got 0.04. Now if we do the second iteration, we have to take this value T is equal to 0.1, C is equal to 0.496 and CV is equal to 0.004 for next iteration. Okay, so similar way we can do the calculation. Now if we do that 20 iteration, means at T is equal to 0, T is equal to 2.0 second, so we will get that CA will be 0.4274 and CV will be 0.068 second. Okay, so means here initial condition T is equal to 0, CA is equal to 0.5, CV is equal to 0. At T is equal to 0.1, CA will be 0.496 and CV will be 0.04. And after 2 seconds, means if we do the calculation, if we do the 2 seconds, and we will get 0.4247 and CV will be 0. Or not 2 seconds, so that will be 2 minutes. Okay, this is also 2 minutes. Okay, so after 2 minutes, not 2 seconds, after 2 minutes, that CA will be 0.4247 and CV will be 0.068. okay, so this will be the concentration. Now salt in tank A after 2 minutes, so that will be CA into that volume, and ultimately that salt tank A after 2 minutes, that will be 21.235 pound. and salt in tank B after 2 minutes, so that will be CV into 50 pound, so that will be 3.4 pound. Okay, now I'll show how to do in MATLAB.